Since the dawn of time, humans have gazed at the stars and dreamt of exploring the cosmos. Among those celestial wonders, Mars has held a special place in our imagination. Its reddish hue, visible to the naked eye, has captivated stargazers for millennia. Ancient civilizations wove myths and legends around the red planet, associating it with war, passion, and the unknown.
Today, the dream of reaching Mars is no longer confined to mythology. It has evolved into a tangible ambition, fueled by scientific curiosity and the spirit of exploration.
Astronomers observed polar ice caps that expanded and contracted with the seasons, hinting at the presence of water. They mapped dark surface features that shifted over time, suggesting the possibility of vegetation. These tantalizing clues ignited our collective curiosity, fueling speculation about the existence of life beyond Earth. The dream of reaching Mars is now within our grasp. The question is no longer if we can reach Mars, but when.
Before humans can set foot on Mars, we must first send our robotic emissaries to scout the terrain and pave the way for human exploration. Over the past few decades, NASA and other space agencies have dispatched a fleet of robotic explorers to the Red Planet, each mission building upon the successes of its predecessors. These robotic pioneers have revolutionized our understanding of Mars, revealing a world of stark beauty, scientific wonder, and unexpected challenges.
Among the most successful of these robotic missions are the Mars rovers. Spirit and Opportunity, the twin rovers that landed on Mars in 2004, far exceeded their planned 90-day missions. Spirit explored for over 6 years, while Opportunity continued its mission for an astounding 15 years, covering over 28 miles and providing definitive evidence of past liquid water on Mars.
Curiosity, a car-sized rover that landed in 2012, has been exploring Gale Crater, a site chosen for its potential to harbor signs of past life. Equipped with a sophisticated suite of instruments, Curiosity has analyzed rock samples, studied the Martian atmosphere, and even detected methane, a gas that could be a sign of microbial life. Perseverance, the latest and most advanced rover to date, landed in Jezero Crater in 2021. Its mission is to search for signs of ancient life and collect rock and soil samples for eventual return to Earth. Perseverance is also testing technologies that will be crucial for future human missions, such as producing oxygen from the Martian atmosphere.
While the dream of reaching Mars is closer than ever, the journey itself presents formidable challenges. Traveling to and living on the Red Planet will push the limits of human endurance and ingenuity, demanding innovative solutions to overcome the perils of interplanetary travel.
One of the most significant threats to astronauts on a Mars mission is radiation. Unlike Earth, Mars lacks a global magnetic field and a thick atmosphere to shield it from harmful cosmic rays and solar flares. Exposure to this radiation can damage DNA, increase the risk of cancer, and cause other health problems.
Communication delays pose another significant challenge. The distance between Earth and Mars varies greatly depending on their orbits, resulting in communication delays of several minutes even at the speed of light. This delay makes real-time communication impossible, requiring astronauts to be more self-sufficient and resourceful in handling emergencies and making critical decisions.
The psychological toll of a Mars mission should not be underestimated. Section 4. Finding a home on an alien world. Selecting the right landing site for a Martian settlement is crucial for the success of any colonization effort.
One of the primary considerations for site selection is the availability of water. Water is essential for human survival and can be used to produce breathable air and rocket fuel. While liquid water is scarce on the Martian surface, vast reserves of water ice exist beneath the planet's polar ice caps and in the soil at higher latitudes. Choosing a site close to these water resources would greatly reduce the logistical challenges of transporting water or extracting it from the atmosphere.
Another important factor is the presence of natural shelters. Mars lacks a global magnetic field and a thick atmosphere, leaving its surface exposed to harmful radiation. Lava tubes, caves formed by ancient volcanic activity, offer natural protection from radiation and meteoroids. These subterranean environments could provide safe havens for habitats and research facilities, shielding them from the harsh Martian environment.
Elevation is another important consideration.
Section 5. Building a second home on Mars. Establishing a permanent human presence on Mars will require more than just finding a suitable landing site.
One promising approach to habitat construction is to utilize Martian regolith, the loose, unconsolidated rock and dust that covers the planet's surface. Regolith can be used as a building material, either by compacting it into bricks or using it as a component in three-dimensional printing.
Autonomous robots will play a vital role in building and maintaining a Martian colony. These robotic workhorses can be deployed in advance of human arrival to prepare the landing site, assemble habitats, and set up essential infrastructure.
Growing food on Mars will be essential for long-term sustainability. Hydroponics and aeroponics, methods of growing plants without soil, offer promising solutions for food production on Mars.
Section 6. The clock is ticking. As we stand on the cusp of a new era of space exploration, the question of whether and when we should colonize Mars has evolved from a topic of science fiction into a matter of pressing concern.
The drive to explore is deeply ingrained in our nature, a fundamental aspect of what makes us human. For millennia, we have journeyed to the farthest reaches of our planet, driven by curiosity, ambition, and the pursuit of new knowledge.
The colonization of Mars is not merely an endeavor for the distant future, it is a challenge that we must confront within this century. Establishing a self-sustaining human presence on another planet, a backup for humanity, could prove to be the ultimate insurance policy for our species. Section 7. A Martian future? The colonization of Mars is an ambitious endeavor, fraught with challenges and uncertainties, yet it is a goal worth striving for, a testament to the indomitable spirit of human ingenuity and our insatiable thirst for exploration.
The first human missions to Mars will be tentative steps, short-duration expeditions focused on scientific exploration and establishing a preliminary presence.
The challenges of living on Mars will necessitate the development of self-sufficient communities capable of producing their own food, water, and energy.
The colonization of Mars is not a foregone conclusion, but a choice that we must make as a species. The dream of a Martian future is within our grasp, but it is a dream that will require courage, determination, and a shared commitment to push the boundaries of what is possible.